Hello everyone, welcome to IGCSE and GCSE Maths School. Now today, the simplest maths problem relating to lower bound and upper bound, right? Now, question, if A equals B minus C minus D, where B equals 200 to nearest 100, C equals 40 to nearest 100, nearest 10, and D equals 20 to nearest unit, find first part, upper bound and lower bound of A, and range of value of A, right? Okay, let's start. Now, first of all, we take this. This is the statement. A equation equals B minus C minus D, right? This one. Now, this is actually equation where D and C has to be deducted from B, right? As a parameter. We can adjust then for the purpose of finding upper bound and lower bound, for our convenience, we can rearrange this like this. A equals B. I take negative sign out, then it will be something like this. C plus D. Okay, C plus D. C plus D. Right, B minus C plus D. Now this is a difference of two corrected values. B is one value, this whole thing is one value and one value. This value has to be deducted from B, therefore this is a difference. Difference is always found by subtracting one number from the other one, the larger number minus lower number, larger number minus smaller number, larger number minus smaller number. That's how you find the difference between two numbers, right? Okay, now let's see, we want to find upper bound. We know how to find that this is a difference of two terms, this one and this. Then that is what applies here, the how to find the upper bound and lower bound of difference. How to find the upper bound and lower bound of difference. Then we have learned two formulas for upper bound of difference. Upper bound of difference equals upper bound of the larger value minus lower bound of smaller value. Then the lower bound of, we have learned another formula for lower bound. Lower bound of difference of two terms, two corrected values. That is lower bound of difference is equal to lower bound of the larger number minus upper bound of the smaller number, smaller value, right? Then we write this. Then to find the upper bound of this A, we have to take upper bound of B minus lower bound of this C plus D whole thing. Lower bound of this whole thing, right? Then we will write the equation for the upper bound of A. Then upper bound of A equals upper bound. That is the upper bound of difference of two terms. The upper bound of the larger value. That is here the large value. B here is, that's why you deduct this from this, right? Upper bound of B minus lower bound of this value. Then minus lower bound of this one, C plus D. Okay, right, C plus D. Then, right, that is the upper bound. That's how to find the upper bound of A. That's how to find the upper bound of this difference. Then you find the lower bound. Lower bound of A equals, lower bound of difference equals lower bound of the large value minus the upper bound of the smaller value. Then here, a large value is B here. Then lower bound of B, when minus upper bound of what? The C plus D, right? Okay, C plus D. Okay, we found, right? Now you want to find the upper bound of B, lower bound of B, and lower bound of C plus D, and upper bound of C plus D, right? Now the lower bound of C plus D, that is sum, lower bound of a sum. Lower bound of a sum equals sum of the lower bounds of the two numbers that are added, two numbers in the sum. Lower bound of a sum equals sum of the lower bounds. Upper bound of a sum equals sum of the upper bound. So therefore now you write upper bound of B, then B, you calculate here. B, this is working, B. For B, we calculate this. B is the upper bound and lower bound for this, calculating both of the bounds, right? Now you upper bound, the B is upper bound of a single corrected value. Then we know the formula for upper one single corrected value. Upper bound equals corrected value plus degree of accuracy over 2. It right here. upper bound equals corrected value plus degree of accuracy over 2. Right? Okay, right. Now find upper bound of b, that is upper bound of b, you get the corrected value. Then corrected value here is how much? B. Corrected value of b is 200 to the nearest 100. Then it's 200 to the nearest 100, then plus, then degree of accuracy to the nearest 100, that means 100. 100 is the degree of accuracy, then that is divided by 2. Then you are getting here 200 plus 50, 250. That will be the upper bound of what? B. Then you get the lower bound. The lower bound of B. What is the formula? So the lower bound of a single corrected value, the formula, the corrected value minus degree of accuracy over 2, then corrected value minus degree of accuracy over 2. Then that is the corrected value. Same 200, the plus the degree of accuracy is 100, that is divided by 2, then you get, sorry, that is minus. So corrected value minus degree of accuracy over 2, then 200 is the corrected value, that is minus 100 over 2 means 150, that is 200 minus 50, that is the lower bound is 150. Okay, that is found. Then we found the lower bound and upper bound of the single corrected value B. Now we go to find the lower bound and upper bound of this combination of C and that is sum of C and D. We know the upper bound of sum is sum of the upper bounds. Then we write here, we get C plus D. We found. Then what is that? Upper bound of what? C plus D equals what? This is the upper bound of the sum equals sum of the upper bounds. That means upper bound of C plus D equals upper bound of C plus upper bound of D. Then you write upper bound of C plus upper bound of D. Right? Upper bound of D. Okay. Upper bound of D. Right. Upper bound of D. Right. Then we find. Then how do you find the upper bound of C? Corrected value plus degree of accuracy over 2. This one. Upper bound of B. Corrected value of C. How much? Corrected value of C. Corrected values are 40. Then that is 40. Plus degree of accuracy over 2. What is the degree of accuracy? 10. 40 is correct or nearest 10. Therefore 10 over 2. Right. That is the upper bound of B. Then plus the upper bound of D. What is the upper bound of D? That is 20. That is corrected value again plus the degree of accuracy over 2. That is the formula for finding the upper bound of single corrected value. That is corrected value plus degree of accuracy over 2. What is the corrected value? That is 20. 20 plus what is the unit? Unit means 20 has been into nearest unit means 1. When the degree of accuracy is the nearest unit, the degree of accuracy to be used in the upper bound or lower bound formula is 1, right? We have done that, okay, previously. Then, okay, this is the statement for that. Then we will write this 40 plus 10 over 2, that is 45. Then plus here 20 plus half is 20.5. 20.5. Then add those two, you get what? 45, 25, 60, 65, 65.5. Right? That's the 65.5. That's the upper bound of C plus D. Okay. Then go to lower bound of C plus D. All right, lower bound of C plus D. Right. Lower bound. What is the lower bound? What is the formula? This again, lower bound of sum equals sum of the lower bound. Then you can write this as the lower bound of C plus lower bound of what's that? D. Okay, lower bound of D. The lower bound of C is lower bound of a single corrected value, degree of accuracy, corrected value plus degree of accuracy over 2. Again, the lower bound of D, that is also a lower bound of a single corrected value. The formula is corrected value plus degree of accuracy over 2. Then define the corrected value here. Lower bound of C. What is the corrected value of C? What are the values C here? C 40. 40. Then plus. Then degree of accuracy over 2. Sorry. Here lower bound upon the degree of accuracy. Lower bound of right. Okay. No problem. Correct. Right. Okay. Then 40. Then 40 here 40 to the nearest 10. Then degree of this 10 divided by 2. Okay. I'm sorry. Then here there's a mistake. Here. Lower bound. Lower bound of C means the correct. The answer is what we call the formula for find the lower bound is corrected value minus degree of accuracy over 2. Corrected value minus degree of accuracy over 2. Right. Then corrected value minus here. Then 40 is the corrected value minus 10 over 2. Correct, degree of accuracy of 10. Then plus, because lower bound of a sum is sum of the lower bounds. This is the sum of the lower bounds. Now we're getting the sum of the lower bounds of C and B. Then for lower bound of D is corrected value minus degree of accuracy over 2. The lower bound of D is given as, the corrected value of corrected value of D has been given as 20. Then minus because we are going to find the lower bound, then minus, then the degree of accuracy is 1 going to the nearest unit. Therefore, degree of accuracy to be used in the lower bound upper bound formula is 1, then 20 minus half. Then you get here 40 minus the 35 here, then plus here 20 minus half is 19 and half. 19.5. Okay, then you get the answer 35 plus 19, 19, 45, 45, 50, 54.5. 54.5. Is it correct? 9 plus 5 is 14, 3, 1, 5, 3, 1, 4, 5. Correct. Okay, 54.5. Okay, right. Okay. Good. Now we have found all these necessary information to find this upper bound and lower bound of A. Then we can write upper bound of what A. We calculate, we substitute. Only thing is to now the only thing to do is to substitute now those things. Then these are the upper bound of B. Where's the upper bound of B? 250. Upper bound of B 250. Then minus lower bound of C plus D. What is the lower bound of C plus D? C plus D lower bound here, this one. 54.5. 54.5. And subtract. Then you will get the answer. What is the answer? 54, then subtract 50. 96. 96, 95.5. Right? 195.5. Is it correct? 0, 4, 9, 10, 1 is left, 10, 1 is left. Right, okay, correct. Right, 195.5. Then our lower bound. Lower bound of what is that? A equals what? Lower bound of A equals what? Lower bound of B minus upper bound of C. Lower bound of B. Lower bound of B is 150. 150. Then minus upper bound of CD. Upper bound of C and C plus D is 65.5. 65.5, right. Now subtract. Now subtract, yes. If you subtract, you will be getting how much? 150, and you remove 50, then you get 15, then 15 again from 185. From 85, 84.5, right? 84.5, okay. 5, 5, 10, 1, 4, 5, 9, 10, 8, 6, 8, 6, 14. Then 4, 5, how much? 9, 10 again. Then 10. 8 is 14 plus 1, 15. Correct. Right. Now to find the this is the answer for the first part. This one. Then second part will be what? Second part will be the range. Range is always the range of actual values greater than or equals the lower bound, but less than upper bound. So that is the format. Therefore, you write actual value of A, then greater than or equals at lower bound, 84.5, then less than 195.5. So that is the answer, right? That's all about the question. It has been fully answered, right? Okay. Then do the question several times and practice very well. And we'll be meeting with another video like this. Have a nice time. Thank you.